Hi, everyone. Welcome to Speakeasy JS for this week. And I'm joined here this week by our amazing panel. We got Michael Rogers and Paul Frazee. Say hello, guys.
Hey.
Hey, everybody.
Cool. And for this week, we have our speaker is Fred K Schott. He's the creator of, say hi, Fred.
Hey, everyone.
He's the creator of Pika and Snowpack. Before that, he did a bunch of work on web components and was on the Polymer team at Google. So he's been thinking a lot about sort of components and module systems and stuff like that for a while. And he's going to share with us his work on Snowpack today. So yeah, and then we're going to do some Q&A and some discussion afterwards for about 20 minutes after the talk. And then we're going to all join the Speakeasy sort of social happy hour session at the very end. So stick around for that, and you'll get a chance to hang out with us and ask your questions directly to Fred if you're lucky enough to get matched to him in that component of the event. So without further ado, Fred, it's all yours. The stage is yours. Take it away.
Right on. Thanks, y'all, for having me. I have some slides. Oh, my God. I have a little, I feel like I'm on the news or something.
Yeah, we do it legit here.
Yeah, I feel like every week there's something added. This is very cool. All right, give me 1 second.
Yeah, you got it.
All right. All right, well, thank you all for having me. Yeah, so I am here to talk about Snowpack and the greater story of a faster web powered by WASM, ESM, and just all that good stuff for web developers. It's coming down the pipeline. I want to explore it in this talk. In case you don't know me, I know I got a little bit of an intro there, but I have been working with ESM as a technology for a long time. That's a type of JavaScript module format that I'm going to get into later. But it's a really interesting technology for JavaScript. It's something you're probably already using today, but this project is all about taking the full value out of that. It turns out we're really just scratching the surface there. If you ever saw the project Pika, that was kind of the first foray into this, and that was essentially exploring the fact that there were these modern packages on NPM and no one could find them. So NPM, having originally stood for Node Package Manager, the Search Console was really kind of Node focused, or at the very least, web ambivalent, which meant that you really had to go digging to find out which packages were optimized for the web. You'd search a term and the top results would have a ton of dependencies or would be using a lot of Node built-ins, just not really optimized for the web for light use and small file size. Pika was essentially the place to go find those packages. So it was all ESM packages, all modern, all kind of web developer focused packages. And it was the first place to search those at that time. The project has shifted a bit though towards these two other projects, or at least these two kind of follow on where do we go from here type projects. The first is Skypack. So if you're familiar with Unpackage or JS Deliver, JavaScript CDN, we're one of those, but with a really interesting take where everything is ESM. So this import statement, that's ESM, the ability to import JavaScript from within the script itself. Essentially that URL being the place where you're going to go and load that code from. We host every NPM package, but no matter how it was written, no matter what the author did, we're serving it as ESM. So in your script, in the browser directly, no build tools required, you can essentially drop one of these import statements into your JavaScript and load any dependency you want. As long as it can run in the browser, it's not doing something like searching your file system for emojis or cat GIFs. But as long as it's literally meant to run in some way on the browser, we will do that work to make it run directly in the browser. No tooling necessary. Snowpack is our more popular project, though, and that's really focused on web app developers. So that's the idea of starting to bring this ESM technology, these imports and exports, to you as a web application builder or website builder. And a lot of this talk is going to focus on what that means, but I really don't want this to be like a talk about Snowpack. This is really going to be about exploring the deeper shifts that are at play that Snowpack is really designed just to take advantage of and to bring to you today. So there's all these things going on in the service that Snowpack basically wraps up in a nice little package that feels a lot like the web development experience you're used to, but much, much faster. Much, much more just kind of lightweight, low tooling, low config, and really fun to use. So it's a talk on Snowpack, but really I want to just kind of spoil the main takeaways. If you take nothing else away from this, it's this idea that web development shouldn't be super expensive. It shouldn't take a giant, full desktop to compile your bundles or to build your website. We've, as a part of modern development, have started to think of your fan spinning up as a natural part of web development. You're running your dev environment, you're bundling your assets together. That can be expensive. We are moving towards a world where that's not true. That's really a limitation of tooling that we're using today, and not of the web platform, right? We build for the web. That's an environment that's meant to be lightweight. It has to load quickly over a network connection of any quality. So really, this project's about exploring that question of why is it so expensive in terms of compute and machine resources to build a modern website when the thing that we're building is meant to be simple. The other takeaway is that bundling is a production optimization. So webpack, parcel, rollup, all of these things meant to be bundling. That's a production optimization. That's the idea of combining files together to reduce the number of total requests you need to make over the network. And it's really easy to hear that and be like, yeah, well, duh, that makes sense. Bundling is for performance and for production. But the question then becomes, well, why do we run a bundler during development? Why are we doing all this work of bundling if it's just an optimization? And so this talk, I want to explore that question and why that is, why we are running bundlers during development. If we don't actually care about performance, we're running it over a local network, we're doing quick iteration. Why are we doing all this extra tooling during development? And the last takeaway is this idea of WASM and JavaScript hybrid tooling, not just being the future, but it's literally here today. And it's really fast. So this is exploring the idea that WASM is here. It's this idea of compiled languages being really good at compute and really efficient with their resource use. And JavaScript being really good at I/O and still the language that most of us as web developers are familiar with. And WASM is only going to get more and more kind of advanced and impressive from this point. It's still kind of early days of that technology. But already we're seeing it being used for heavy compute things that JavaScript kind of had to just find its way through. So bundling as a compute-heavy resource, or a task rather. We see a lot of projects like ESBuild, if you've seen that, is a great example of bringing WASM in for really compute-heavy things. Snowpack lets you combine that with your JavaScript tooling, your plugin system that you're used to. This idea of melding the two together to give you a much better experience isn't like future talk anymore. It's literally here. So I want to talk a bit about that as well. Quick, brief history just of module systems in JavaScript. I know I've mentioned ESM, and what is that? What's the context there? If you were doing web development a long time ago, before there was Node, before there was CommonJS or ESM or any of these buzzwords I'm throwing out, you kind of just loaded things from the ether. Like there was this global window object and dependencies would attach themselves onto it and you would pull them out and just kind of pray, do a little song and dance, hope that it was there when you finally went to load it. If you've ever done development like this or seen this in your own stack, like you know what I'm talking about. It's just URLs being loaded and then you kind of just hope that they implicitly have injected themselves into your environment. This was just the world of not having a module system that was unified and in the browser. There was no module system, so developers kind of had to bring their own. And each package would bring its own. And if you were working on a project or at a company, you'd kind of bring your own for the company. So you'd have an idea of what does a component mean, a module mean at my company on my project. But it really was like this Wild West mentality of, it's just a script, it's just an environment, and it's your job to bring structure to it. CommonJS was Node's take on a module system. So the Node community got together and they said, this will not stand for what we're trying to build. I'm adding a little bit of editorializing, but this idea that Node needed a module system, it needed consistency. And so they were pretty paramount in building and designing this CommonJS module system. This idea of every file is a module. You have this require function that you can load code off of the file system or out of your Node modules directory. And you have this exports or like module.exports object that you can just kind of attach stuff to. And that'll be our module interface. So really straightforward, really simple from that point of view, and super consistent. So every file in Node followed this pattern. And then NPM, the Node package manager ecosystem, kind of came along for the ride, right? There was the ecosystem of Node, so it would, of course, adopt that same module system. Web developers ended up being like, oh, great, consistency. This is fantastic. One community, every package, everything's following like kind of a standard set of modules. I can leave behind this Wild West and kind of, maybe it's not optimized for the web. Maybe it was designed with only Node in mind, but I can use tooling to kind of find my way through. And that consistency, that growing ecosystem of developers that I'll have access to within NPM, that's worth it for me. So if you ever use Browserify, and if you're currently using Webpack, those were all tools that really came about to solve that problem, make CommonJS code run in the browser. ESM is the modern native take on modules. So CommonJS comes into popularity. It's big, it's popular. A lot of people start using it. At the same time, the standards track of just JavaScript is exploring this problem that we don't have a module system that runs on the web. If you've seen these two together, CommonJS, it's consistent, but it can't actually run in the browser natively. That require function, right? What is happening in that code example is Node itself is blocking essentially when it sees that line. It says, okay, I got to load some file. Let me go check the file system for this. I'm going to go out, find it. Sometimes you don't even add the file extension, which means, okay, I don't have a file extension. This could be a directory. This could be a file without an extension. It would go and do these multiple lookups that was blocking. This was fine because it was local. It was file system. Not great, but certainly not end of the world. But in the browser, that would never make sense, right? You can't go and make multiple blocking file requests in the browser when that might take a full second per file if you're on a spotty connection. So CommonJS was popular. It was consistent. It was great for the Node community, and web developers kind of came along for that consistency and that size of the community. But it was never meant to run in the browser directly, and it just really couldn't. Webpack essentially came in, and the answer to why do we use bundlers today during all types of development for the web, it's because we are building on top of an ecosystem that was never meant to run on the web. Webpack today is not just a production step. It's actually the compatibility layer for all web developers who access NPM. So ESM was essentially designed to try to solve this, give the browser a primitive that would work asynchronously. So you can import from some file, and actually your browser will go out and in parallel load all these different files. There's no ambiguity. It has to be an actual file there, so there's no multiple lookups per request. And it gave you this really, really explicit import statement, really explicit exports that then let browsers and also bundlers today optimize that code much better. So ESM has benefits whether you're using Webpack or not using Webpack. It's a really, really explicit language, which just means you can optimize for it at all levels, both in the browser, but also at a bundler and some sort of processing that can read this code and see exactly what you're importing and eliminate dead code. The cool part about this as a big technical advancement is that a lot of us are already writing this. You were probably already writing this today in your applications and on your sites. Because of the prevalence of build tooling and lots of tooling, we kind of found ourselves in this nice place where developers could bring this tooling into their apps, even if they then ran it through Webpack and converted it to CommonJS and went back into the old world for their production deployments. We still got to write ESM. So this has been around for about 5 years now as a kind of standardized spec. It's really popular. It's not some big, this is coming soon. It's kind of here. Most tools support this by default today. So the big question that Snowpack explores is, given this history, given that we finally have a primitive that actually runs in the browser, a module that runs in the browser, whoa. I don't know what just happened, but I'm still here. So hopefully y'all can still see me. What happens when you have this new primitive, this thing that the browser natively understands? Well, how does that change web development? It's got to change it somehow, right? This idea that tooling was a solution to a module problem, by changing the module, we must get some impact on the types of tools that we use. I want to go through a few of them today, and in this kind of show through slides, and then if there's time left for a demo, I'll do that. The first one is that bundling during development means you need to do a lot of work up front. Just to serve the first kind of hello world view of your app, you need a bundle, right? You need to get all the assets together into the bundle. That means building them, bundling them, that's your site. The cool thing about removing that from the equation, at least during development, is that starting up your dev server essentially just becomes this really, really cheap instant task. There's no ahead of time work that you need to do because everything will be unbundled. It will be delivered as ESM. So no bundling, files are delivered in a way that the browser can understand, means the server just kind of starts up and waits for the first request. Snowpack uses this really, really interesting basically design choice that the server does no work, and it's the first request that kicks off the first file build. So you load your first kind of index.js, that's going to be the first thing that starts building. What that means is that your site and the kind of amount of work that it takes to run your site is always going to essentially match however much is on the page at any one time. So you could have thousands of components, thousands of pages, millions of JavaScript files theoretically, and whatever's on the page is what's going to build. Everything else just kind of sits there waiting. If you go to that page, then it'll build. If you don't, great, you've just kind of skipped that work. So not only are you not bundling, which is no longer necessary when the browser understands the code that you're writing, but also you're only having to build the code that you actually run. So it's this really, really tight feedback loop. You're never doing unnecessary work. The other really cool thing that this allows is a much faster kind of dev speed overall. So not only are we doing less work by not bundling and only building the files that we need, but this idea that when you then save a change to a file, a bundler is going to have to reincorporate that change into a larger bundle. So it's going to have to, in some cases, fully rebuild the site, or at least rebundle those assets together to then deliver the update to the browser. It needs to resolve the change you made to that one file with its larger view of how bundles work. To compare that to Snowpack or an ESM dev environment, every file is built individually. So the idea is that when you make a change to a file, there's no larger bundling at play during development. You essentially change the file, rebuild the file, ship that update directly to the browser, and that's it. So not only is it a really light amount of work, right? How long does it take to compile one file? It's really fast compared to a giant bundle. But also the caching story there is really interesting, because now, essentially, if you never change a file, we can reliably start to say, okay, well, you know what? We can keep reusing that build, that original build we did the first time you ran this. Obviously, configuration and how you configure the build tools, they need to be accounting for that. But this idea that every file is not just built once, but it's also then cached until it's changed. So you get this really, really light and really efficient cache reuse when you're building a site with Snowpack, because every file is individually just kind of one-to-one. It's just you're just building that one file.
Hey, Fred, could I interrupt you for a second to ask a question? Yeah, raise my hand.
Yeah, I cannot see anything except my own slides, but thank you for calling me.
Okay. Yeah, no worries. So my question is how much of this is how much of the benefit that you just described about this sort of quicker build and only needing to build, do the build and not do this whole bundle recompilation thing is due to ESM, and how much of it is due to the work you've just done in Snowpack? Because it just seems to me like you could, in theory, build stuff into all these different files and then load them with normal script tags. Am I understanding that correctly, or is ESM doing something special here?
Sort of, yeah. Yeah, you could take that kind of old school approach, right? Or every file is a script tag, and kind of bringing your own module system to the browser is essentially what Webpack does. So you could kind of do this in some other way. What's nice about ESM is that it's just built into the browser. So the idea of the URL that you're loading a file from, that gets then cached by the browser, and kind of the module is kind of located at that URL. It just has a really nice mapping of one-to-one between the file on the disk and then the browser understanding what it means to load that file. It means there's no kind of compilation to, okay, take this ESM that I'm writing and now compile it to something that would run in the browser in some other way. Yeah, we are definitely standing on the shoulders of giants in the terms of we're kind of just using the primitives that the browser gives us. We're just one of the first people to really use it and design for that primitive versus trying to match that primitive into an older model. The other is that what we do behind the scenes, which I don't talk about as much here because what's nice is that we kind of just automate it, is the idea that NPM packages are still, by and large, this common JS format. And so what Snowpack is able to do, kind of the magic of it, which we've pulled out into a package called ES install, I would definitely recommend checking that out if this interests you, is the idea that we can take any package and up-convert it to ESM. So that was kind of always the missing piece here, and the reason we always basically down-converted entire sites to legacy formats like common JS. The reason was that, well, the packages we're using can't be up-converted, so we'll just match them instead. We'll kind of downgrade. Snowpack takes the alternate approach. It says we're going to up-convert the package to ESM. So now when I say load React, I'm actually still letting the browser do its thing and load this script called react.js that we have done the work to essentially turn into an ESM file. So a lot of the heavy lifting that we've done up to this point is really around that story of bringing your dependencies up to this world and along for the ride versus you having to down-convert to match them.
Cool. Yeah, thanks for letting me interrupt you to ask that.
Yeah, no problem. Yeah, keep them coming. Keep them coming.
Cool.
Yeah, it's really the story of that single file builds that is powered by ESM in the browser that lets us do this. So 50 milliseconds was when I originally created this kind of sketchy drawing. We've gotten that down to 30 milliseconds, and the place where WASM comes in is that there's this really cool tool named ESBuild. So ESBuild is essentially, it's marketed as a bundler, but it has just as much about transforming one-to-one files as well. It's written in Go. It's by, and I'm kind of blank on his name, but Evan something. Evan is awesome. It's a great project. Check it out. I'm sorry, I don't remember your last name, Evan. It's awesome though. And so it's written in Go. It goes really fast. It's compute kind of at that WASM compiled level, which means that we as Snowpack are essentially just coordinating that. So that's our default builder today. We see your file on disk. We pass it through ESBuild. That does the heavy compute. We get the output. and that's what gets sent to the browser. So per file, we're down to essentially 10 milliseconds of actual build time. Of course, that is variable based on the size of the file, but we're talking about when you're building single files, really, really quick responses from the browser, or from the dev server, rather. The last thing here before I go out and do a demo is just this idea of simplifying configuration. And this is obviously very much dependent on how much configuration you like, how much you want to bring to the table. But I want to call this out specifically because it's a different model for configuration. The idea of bundlers as the base primitive, the base kind of we are building for bundlers, means that everything you're building for is kind of building in this context of how does it all bundle together. That's a much more intense kind of approach to building versus just how does this get to the browser. You're saying how does this get to the browser through a tool pipeline, through a really kind of complex, there's a lot kind of taken as kind of just always on when you're in that model. So when that's the configuration you're building for, that ends up being the way the kind of prism you see everything through. You certainly can build long, big configuration files with Snowpack, but the idea is that once you move to that one-to-one file build model, everything becomes really composable. So the idea of Sass, for example, to compile something from Sass to CSS, that really just hooks in at the file build level. You don't need to worry about what does that do to your bundles and how does this kind of recompile and all the things that a bundler kind of takes as gospel. Instead, you just need to worry about getting a Sass file to CSS. And that's the only hook that this needs to kind of plug into. TypeScript, if you want to add linters or type checking, you can do that through just essentially connecting the TypeScript CLI directly into your kind of dev console. So it's just kind of running a CLI to get type checking. Plugins that kind of expand your environment, enabling fast refresh with React, and then even connecting a bundler itself, right? This idea that we're doing an unbundled build, all that means is that we're going to output an unbundled website. That can still go into a bundler at the end of the day to then bundle it up. So what's really cool about this, and the reason adoption is really picking up, is that we're not actually asking you to change much about the end result. If you like bundling, please, in production is a great place to bundle. But bundling is no longer the lower level language you're speaking. It's just a production optimization. It's something you attach to your dev environment for production. And everything else that you use can then speak a much lighter touch language of how do I hook into this build? How do I transform a file? Versus having to worry about the impact on bundling that every plugin might have. The other cool thing that I'm really happy we were able to get, this was kind of the first thing that we tackled, was this idea that you don't need a fully featured plugin ecosystem to start using your tools and connecting them to Snowpack. This idea that because we have this really simple input-output, one-to-one file builder, you can essentially connect any CLI to Snowpack without a plugin using one of these utility plugins. So plugin build script essentially says, pipe the input, any file, Sass, CSS, JSX, pipe it through this CLI. That's the standard input, and then the standard output, the output of the CLI will become the file result. So we got jump-started really quickly. Essentially, any tool that you want to use, as long as it ships a CLI, you can connect it to Snowpack as a part of your build. That also just translates to any CLI as a sort of type of feedback, output, type checking, linting. You can also just connect a CLI in and have the output piped directly into your dev console. And when you go to build, you can essentially have that be a check. If it fails, the build will fail. So Svelte check is a really cool project by the Svelte team to essentially just do linting and certain checks on your Svelte code. And with this configuration, you essentially, without any sort of special plugin, are just connecting that CLI directly into Snowpack and getting that output as you develop, and then finally when you go to build. So before we get here, I do just want to kind of show a quick demo, because demos are fun. And I also just want to show how quick this is. There's a project called Create Snowpack App. Let me just build this really quickly. I have it here. So Create Snowpack App is like our take on Create React App. It's the idea of a CLI that you run, and you give it a template, and we will essentially kickstart an application for you. You can search for that on our doc site on snowpack.dev. We have a bunch of templates, React, Svelte, Vue, lit element, and then all of them usually have a TypeScript component if you like TypeScript. So it's essentially just a suite of templates that you can use to kickstart your development. What this does is it essentially pulls it from NPM. It's the template exists as a package on NPM. It installs it into your directory, and it gives you a bunch of just kind of setup, opinionated setup things that you can use. that I cannot type on code and talk with words, but hopefully that made sense. What you have here is npm start. So this is going to be the basic Snowpack dev command, and I will make sure that this runs. Here we go. So already you can see here that we have a kind of already pre-configured application. You have an app component, gives you some instructions, some CSS, a kind of main entry point here for React DOM, and then some kind of public, just assets for you to use. Now in the output here, you saw that the first time you run this, we need to do that up conversion. So we call that installing your dependencies. A little bit confusing because you already npm installed them, but essentially we're taking them out of your node modules directory and we are turning them into ESM JavaScript. So we've taken React and React DOM in this case and turned them into 2 JavaScript files. As you type, as you add new imports, we'll essentially keep doing that. Anytime we detect a new import, we'll reinstall with that new import, with that new package, and you can have this kind of just pretty rapid development without having to quit the program, go and reinstall, do any of that stuff. What I want to really show you all here is the idea of what the network looks like when you load this app unbundled. So in a traditional bundled development environment, you would have kind of these hashed combined files being delivered right to the browser. Instead, and please call out if this is not big enough, I will try to make it as big as possible while still showing something. Instead, if we can just load up the HTML.
Yeah, could you make it bigger?
Command
plus will do it if you just do it in there.
Yeah. All right. We'll just, is there a way to show? Yeah, great. I'll hide the overview for now. Okay. This idea, is that big enough?
Yeah. You can also hide the settings that you expanded. Right?
Oh, yeah. How does that? Aha. There we go. Great. So you can see here, if I just restart that again, every file is being loaded one-to-one. So you can see here app.js, let's see, React and React DOM. These are the now up-converted ESM packages. And you can tell that they kind of load from these other chunks, this other shared code within your dependencies. So you kind of create this other dependency tree that has been essentially bundled, taking everything within React into a single or 1 or 2 React files. App.js, it has some extra code added for the environment that you're in. We have React fast refresh connected, so that is going to add a little bit of code as well, which I'll show in a second. And then you have, if I just open them up together side by side. I'm really running out of screen real estate. You have this idea of your component here being essentially your module being compiled into JavaScript, your JSX being compiled into React components, and all runnable in the browser as JavaScript. So even though you're writing JSX or you're writing TypeScript, both of those are supported by default in Snowpack, so no extra tooling needed for that. The other thing that we do that's not strict ESM, but something that so many developers are familiar with, we do it anyway, is this idea of importing images and CSS within your JavaScript. So here you can see that we have this idea, if it's not natively JavaScript, we will just turn it into this proxy file. So for images, that's just a reference to the final URL. So you can do something like putting your logo in an image tag. And for CSS, we actually load it in as essentially a string that then gets applied as a style element to the page itself. And not only does that make sure that the CSS loads with the JavaScript of your application, but it also allows you to connect some HMR, some hot reloading, so that when you go and change this file, like I can do here, we'll make our, what should we do? I want to make sure it's visible here. We'll just turn the link red. That's kind of simple. See really quickly, it's being updated right in the browser. The way that works is with our ESM HMR library, so a bit of a mouthful, but ESM being the module system, HMR being hot module reloading. And that's an engine that we developed, and it's a separate project that others can take advantage of to essentially pump updates to the browser, still using the native module system. So this is all kind of native HMR versus most other bundlers, they kind of have to re-implement their own. The last thing I'll show, which is a little bit more fun, I'll shrink this for a second. So we kind of turned it back to blue there. If I make a change here, like let's make our counter go backwards. What happens here is, my code has a race condition, or at least it's not doing cleanup properly. But what happens here is that the update gets pushed to, I'll show you with a clean slate. The updates get pushed, and this is React fast refresh. So I'll just turn this to all caps to show a better example. That gets pushed without changing the state of the component. So React here it has its state internally. It's just pushed a totally new version of this file, but the state has persisted across that. So no matter how many changes you make, you can kind of keep the state of your application in check. Obviously, if your code is a little more bug-free than mine. But yeah, each of those updates comes in as a individual file. So you can see it being loaded here. And then our HMR engine is what kind of calls the proper functions within to apply it into the application. There's a lot more here. It's really worth exploring yourself. You can kind of choose which directories you want to mount, and you can essentially just add whatever plugins you want. So here we just have, as an opinionated setup, React refresh and a .env for loading .env files. But you could add a bundler. You can add anything you want. It's a really extensible platform to build on top of. And I can't go without showing essentially, where'd it go? I messed up my thing. But yeah, you can see here the original app.js file took 10 milliseconds to build and then load. An update took 20 milliseconds to build and then load. So really, really quick iteration on those as you're developing. I'll end with just I'll really breeze through these because I think they're all questions worth discussing with everyone. But here's my take on what this means for the future of web development. That idea that bundling is just a production optimization. It's not something you need to have. It's not something that needs to spin up your fans every time you're developing. It's not something that needs to slow you down during development. It's purely for production. This WASM-JS hybrid that we have already implemented, it's not a future concept. It's already here. ESBuild as a project is exploring their own plugin ecosystem, which would be JavaScript plugins. So really leaning into that idea, it's a JavaScript build tool. Developers know JavaScript. That's the plugin language that we're still speaking. So really, really that is here today, or is ready for us to play around with, and probably will be the future for the foreseeable kind of short term, just given our familiarity with JavaScript as web developers. And then last is I hope that this has showed that ESM as an actual primitive for the browser is unlocking new ways to think about web development. So Snowpack exists to explore this idea that we are doing too much. We don't need to ship our own module system to the browser like we've had to do essentially for the last 20, 30 years. We can just build for the one that the browser has, and with that, send these really quick updates, have a really light touch tooling, and have a really speedy, quick, snappy dev environment. A few really cool kind of directions we're going from here. Our SSR story is really being explored right now. So we're working with the Svelte team to kind of just demo what would Svelte SSR look like with Snowpack. Static site generation, the idea of what would it look like to, if you're familiar with an 11D type static site builder, to have something like that, but as a Snowpack plugin. And the kind of white whale that I'm hunting, that we keep making these incremental steps towards, this idea that why have an npm install step at all? If we're just doing the work of upconverting these dependencies for you, that's essentially what Skypack.CDN that I explained at the beginning, that's essentially what Skypack is doing already. So why do we run npm install and then pull them from your node modules and run all this tooling? Instead, we can pull them directly from the CDN. You get your ESM dependencies, and Snowpack becomes the caching layer, the thing that essentially coordinates that, serving them up to you when you need them, and then including them in your final build when you're ready to go to production. So that would essentially be web development without npm, the CLI, but still obviously using all of the same packages that exist in the registry. So it's a really exciting direction. We keep making steps toward it, and I'm really excited to get that out sometime soon. And yeah, if any of this has been exciting, please come join us. The two projects I mentioned, Snowpack and Skypack.dev, on Twitter at PikaPackage, and Discord. We have the links on the site. Come check it out. Come join us. It's a lot of fun. Yeah, that's it for my slides. That's it for the talk. I hope you all enjoyed it.
You're muted for us.
Thanks for telling me that. Yeah, so I was saying, great job on the talk. That was amazing, super interesting. You're on a panel right now with a bunch of people who are like OG Browserify people. So I'm sure there's a lot of opinions and a lot of questions in the minds of Paul and Rod.
Yeah, if I stepped on any toes, I'm sorry. If I misquoted anyone, please let me know.
No, it's all good. Yeah, so I just want to say I think I totally sort of sympathize with the fan spinning up problem that happens in development. I used to use a MacBook 12-inch, which is like a super underpowered computer that when it came out, it was actually less powerful than the iPhone, the latest iPhone that was out at the same time. And it had 2 cores. And for a long time, when I was just using Browserify, it was fine. It's like a single process thing, and it was mostly using like little tiny modules, and so there wasn't that much code. I was sort of picking the most hand-picked kind of straight from the farm modules, whatever, like very like small and hand-picked ones. And so it was working okay even on such an underpowered machine. But then I switched to I started working on a sort of more of a front end project, and it was less about like a specific package, like a module developer would do, and more of like a sort of a full featured app. And then there ended up being like 2 or 3 different Babel compilations happening like at the same time, and it got to a point where there was, because there was like 3 compilations happening every time I had to save a file. I needed to get a new laptop because the 2 cores was just, you're getting completely hammered, and then there was the 3rd one just waiting, and it was like a 15-second refresh loop. Yeah. And so I just said, screw it, I'm buying a new MacBook with 4 cores just to like solve this problem.
There's an amazing developer in our community who is a paramedic as the day job, and essentially will be doing development out of his ambulance while he's waiting for calls. Like super underpowered, super lightweight machine, but same exact problem. Couldn't actually do development in like a larger, heavier build tool. Like Snowpack was like the way that he's able to do that kind of lighter touch development on a lower powered machine. So yeah, that's a total, like I've had that problem myself on my like little MacBook Air. Was not very good at the bundled approach.
Yeah, totally. It's just it's shocking how much stuff is happening. You install a couple things, you install Next.js, you do a couple of whatever, maybe throw in a little bit of TypeScript, you throw in a couple things, and then before you know it, you literally can't like the most expensive computer you can buy can't handle. It's ridiculous.
But it's those tools trying to do the best they can for their user, right? It's like if complexity is assumed, then our job is to hide the complexity for you. That means doing that work for you so that you don't have to ever look at it. Like Create React App as an example of 600 lines of config, their job is to hide that from you because that's what you would need to implement otherwise. It's a totally different approach where that complexity isn't assumed. It's you can pull in what you need. So pull in a bundler when you're ready for it. If you're building a site for your family, your mom and pop, you probably don't need a bundler.
Mm-hmm. Paul, Rod, you guys have any thoughts?
I did have a question, which I don't know if this is a great question, but I hadn't seen the hot module reloading without page refresh. Is that something that's like hooked into React? Is it understand React and that's how it's able to do that? Because I'm really surprised that you didn't have to refresh the page to inject the new code.
HMR is like black magic, like scary, but very powerful. It is provided by Snowpack so that we basically provide the primitives, but then it's up to usually the framework to understand what does it mean to apply an update to a React app without changing anything, while keeping the state. So HMR as it exists in like Create React App or Snowpack, it's essentially those primitives that allow for it. And then React Fast Refresh is a package created by the React team to allow for the update without changing state. So Snowpack will get you up to update without a full refresh. Yeah. But normally without understanding how React works or how Svelte works, we just kind of have to reset the whole app back to its current state with the new code, but nothing's persisted state-wise. Fast refresh and prefresh is the Preact version, and Svelte HMR, I think is the name. Those are the 3 projects I'm aware of that we've all incorporated into those default templates for Snowpack. So React, Preact, and Svelte all support it.
That's very cool.
For a long time, I just tried to keep my project simple enough that I could do a full refresh and not feel the pain, because it seemed to me like hot module reloading was solving almost like a fake problem in a way. This problem of like, why did we get ourselves into this place of such a slow refresh that we had to sort of do this fancy, complicated thing, which for a long time, there's always little edge cases here and there where it doesn't quite really update the state correctly. And so just to get that integrity that when you really want to test if something worked, you end up doing a full page refresh anyway, just because, at least for me, I don't trust that the thing is going to work correctly. I think it's getting better, and it's definitely like has less bugs than when it first came out.
Yeah, I mean, you saw it in my example. There was a bug like that's in the template. So yeah, it's definitely hard to do right. And you're totally right. When you have a lighter build, if you just refresh the page and everything's cached, over the local network, that can take really, really not much time at all.
Mm-hmm. Yeah.
Compared to having lengthy build steps is really no big deal.
Mm-hmm. So actually, that brings up a question. Like, are there how does the browser? Because the browser has like a concurrency limit on sort of how many HTTP requests you can have going at a time. When you're in development, do you ever hit anything where like someone has 100 modules that they're all sort of at the top level, and then you get like 100 HTTP requests, and then that ends up being maybe slower than the old way of doing it.
Yeah, it's a kind of a pain of HTTP 2 as the more modern, and now H3 is coming out. Both really quick, able to do multiple requests in parallel. The problem is that they require HTTPS. They require essentially a certificate. There is no way to do it that I know of without that. So it's a little bit of extra setup to basically create a fake, or not fake, but a dev key and a dev cert, and basically bring that into your local development. So you're actually doing local development across an HTTP2 connection. But once you get there, I mean, you're loading everything in parallel. So it's not only over the local file system, but it's also in parallel. We've been working on some pretty big apps, and we still haven't, even on HTTP1, even on like the default localhost connection, still haven't really seen much of an issue. When every request is essentially cached, and we use a 304 header to represent that. I think that's it, the E tag 304. The browser actually doesn't end up making more requests than the one file that updated. Or it makes those connections, but then the dev server is essentially like, I'm not even going to send you a body. I'm just going to send you the didn't change. Go ahead and make the next connection. It's pretty quick.
Is there any reason you couldn't? Is there any way you could send sort of an immutable header and just tell it to cache it forever? Or is that not possible because the file name is the same and it's changed?
You know what? So that is a great question that we should explore more, because what you could do is have HMR tell the browser, hey, this thing is no longer valid. Kill the cache. But the problem is that if the browser has no way to know that the file's changed, you can't cache it forever because it might change and you wouldn't know. Part of local development is that any file might change.
Mm-hmm. Oh, right. And I see. So in a traditional bundler, what you would, or like a traditional system, you'd say every URL to every file would have a hash in it, and so when that changes, you end up having to sort of update every file that includes that, which causes that file's hash to change, which causes you to need to update the whole thing. And you can't do that in Snowpack. You don't want to do that because that sort of defeats the whole caching.
Yeah, and we just really haven't seen a need for it in local development. Webpack, by bundling, the one thing they do get is it's one file during development. So even though you don't need production optimization during development, for what you're describing, it would solve that problem. Yeah, but I mean, on local networks or even within your company kind of Wi-Fi, if you're talking to a server that lives in the cloud or on your company network, it's still pretty quick. Mm-hmm.
We had a question from Twitch asking for a comparison between Parcel and Snowpack. Do you have any thoughts on that?
So speed-wise, I think I originally took their benchmark and then added a snarky like Snowpack 0 milliseconds to like how fast we were, because we're not doing bundling, right? So at that level, it really doesn't help to compare to bundlers because we're essentially not doing that work. So the work of a bundler would be 0 seconds on our side.
So Parcel does traditional bundling, whereas y'all do not.
Yes, but everyone does kind of building, right? So they still use Babel, I think, by default to build each file that they serve. We are, much faster than that. I haven't done a benchmark. I don't know if one exists, but it really is to a certain extent apples and oranges between a dev environment where you start up and every file has been cached and reusable, to one where you need to do that recompilation whenever you change a file.
Right. That makes sense.
I'm sure that they would say it's not that bad. And that's kind of one of we do need a good benchmark for large projects, because I think I saw one other question come through the chat of like, this seems pretty comparable. With small examples, it's as the project grows that bundling becomes more and more expensive because you have to do this upfront work for files you might not even be using. That's where the simplicity of only build the files you need and load on the page comes into play.
So it seems to me that a lot of the complexity of what you've built here is about bridging the common JS world to ESM world and the HTTP world with the HTTP2 plus world. And I'm wondering what your view is of that future and the transitional state that as we move towards the future stack. I've had Michael Rogers in my ear, which I'm sure you've heard as well, about this stuff. And I've basically converted to the ESM world now. And so everything is sort of down compiled to common JS for those that want to consume it there. But I am seeing this place where if your stack is just accepting this new world and you're not doing the up compiling that you're doing, then a lot of that complexity just goes away. The ESM is built into the browser. HTTP2 has ideas about parallel loading in it, and so the bundling just goes away, and all that sort of stuff goes away. In CommonJS, you just can't escape that. So I'm wondering what your view is of that future path, the transition there. You seem to be, by doing all this work, you seem to be accepting the fact that this is going to be with us for a long time. Is that how you see things?
Yeah, that's a really good kind of summary of it. And I think that the work we're doing on the Skypack Snowpack integration is probably the best kind of idea of what this looks like, not just like today, but once, we're really in like the first inning of this. If like you imagine like comparing where bundling is today to where ESM driven development is today, it's year one versus year, like essentially 8, 9, 10. So yeah, you're right. There's a lot of just like stuff that's still being explored, but our biggest kind of vision, or at least kind of the strongest light in that vision, is the idea that it's not just ESM as the kind of more powerful primitive, but it's also loading code by URL, which you see Deno exploring as well. And I think Ryan talked about this at one of the last speakeasies. This idea that once you can load it by URL, the whole npm install workflow starts to become not irrelevant, but unnecessary. If you can just load code on demand, the idea of the package from npm and being resolved, all those test files and metadata, all you really want when you load it is just the JavaScript. So if we could serve that from a URL, load it and cache it, that's a really big deal because it kind of democratizes that whole idea of npm as the only registry. If you can load by any URL, Deno, they're using Git and GitHub as their kind of resource. We're still using npm, but with a total eye for that. The great thing about URLs on the internet is, any URL is kind of equal to another. You can pull code from any registry, not just npm.
To elaborate on this train of question, the state of the browser right now, you can do a lot of stuff in terms of actually putting together an application with absolutely no help from tooling, no build step or anything like that, just using native ES modules and loading it into the page and things. There are definitely some pieces that are missing compared to something which Snowpack gives you, such as like we don't have import maps yet, so you're going to have to be putting the full URL pretty frequently in your code. We don't yet have the ability to load CSS or similar through the ES module system, which can be a bit of a pain. What else do you think is missing on that front? And do you think there will ever be a point where projects like Snowpack are no longer needed?
That is a great question. I don't know the answer. I think that is exactly the direction we're taking with this, which is like, there's certainly a future world where Snowpack just kind of melts into the platform, right? This idea of I'm writing ESM and the platform gives me a way to import CSS, which developers like. It gives me a way to import a dependency. There's a certain world where, an import map and maybe a few other things would kind of get you there. There's some things that I don't think we have a good answer for yet, like the idea of if I loaded a dependency, how do I make sure that that's cached? I'm not, every time I refresh the browser, going and hitting an external network. A lot of what our integration is about pulling that through Snowpack so that we can be the cache for you. But yeah, I mean, it's not a zero build tool kind of environment that we give you, but it's really meant to kind of melt away. And if you just use the default config, it gives you a lot of things for free that essentially feel like they're a part of the platform.
Yeah, it still strikes me that even if we were to get all the way there, you would still probably always need a bundler at some point. For production, you probably don't want everything to be broken up in individual modules. Yeah,
that's the part where at a certain point, because of compression really being like H3 and HTTP3 is really interesting in that it lets you not just like kind of parallelize requests, but also like optimize for that, where if a packet drops in one stream of one resource coming down, it doesn't block the whole connection. There's a world where that becomes faster than one large JavaScript file or two large JavaScript files because you're able to optimize for that. But compression is still the thing that we haven't figured out. In that world, compression is still much better at larger files than smaller files.
If you were...
Oh, that's me with the next to a fire station.
You would probably still need to have something like the a server push involved, right? Because like if you're doing them broken up in individual files, you're going to have the like entry point come down, and it's going to tell you what modules it needs, and then you're going to do this back and forth pulling down the individual files. So if you were trying to make something which was as close to a one-to-one with a bundled JS versus still being in individual files, you probably still need the server to do an optimistic push and be aware of what those dependencies are going to be. Is that accurate? Yeah.
Yeah, there's a couple of different ways to tackle that, though. So our default optimization plugin, the default build is unbundled, and you can bring in a bundler if you want. But the default build is unbundled and includes module preload tags in the final result. So we'll essentially at build time go out and resolve your whole tree of JavaScript dependencies and kind of bubble up what each of those are, so that when you go to load it in the browser, you're essentially loading every file in parallel. Skypack does that as well with the kind of optimized URLs that we give you. So that's the best idea that we have for that. Push is another option, but the problem is you just don't know the state of the user's cache. So you might be over pushing resources that they already have cached.
Right.
Well, and that brings up the connection between cache and compression. That in a world where everyone's using URL module, absolute URL module loading, and we're all doing it together, we're all deploying our sites with it. Instead of bundling, the user ends up actually not having to load as much code for each site, because all that common stuff is being fetched from the same place, and so they've already got it in cache. So the case for compression goes down a bit in a world where we're all sharing the same resources that we're loading from absolute URLs.
Yeah.
The optimistic future is we're using absolute URLs like the Dino model, and everybody's browser cache is full of all the same modules that we use. And the only thing they're loading is the custom code, which is ultimately quite small on almost every website out there.
Yep.
And that's really not a huge amount of code.
Yeah, that's exactly what Skypack is exploring. This idea that, if you imagine every website, this is a total simplification. Every website's built with React. Every time you go to a website, you're downloading React over and over again. And right now it's locked away in those bundles. In a world where that just lives at a common URL, now everyone's using the same version of React. Sites don't need to download that dependency. Take that to all of your dependencies, and all of a sudden you're arriving at a site with 90% of it already downloaded and cached on your machine.
I hate to be the bearer of bad news, but I don't think that actually will work in modern browsers anymore. They're doing this thing now where they're partitioning the cache based on the origin that the site that requested the file is. So what that means is, like, if I load some React file from the Skypack URL, then another site wants to load that same React file, exactly the same URL, and it's already in the cache. The browser will literally go out and get it again and not use the cache.
Yeah, I think Safari is the only one that implemented that, but I think Chrome or Blink just started making pushes for it again. Yeah. For us, this is a total. This is a total long-term vision for us.
Yeah.
For people who aren't aware, the reason they're doing that change is because if you imagine a site loading 20 different JS files, and then another, and that's sort of, because it's almost like a fingerprint of, like, if those 20 files are in your cache, then it's very likely that you visited that site. And so then another site could basically figure out that you've been to that site by requesting those same 20 JS files and then timing sort of how long they take to load. And if they're all really fast, then it means they were all in your cache. And so it's very likely that you were on that other site. And so because of advertisers and malicious people, we can't have nice things. And
yeah, that is the story of the web.
We still don't lose all the benefits, though, because even in an unbundled world, we still are caching the things that are common. Like, your version of Lodash is not going to change that much between releases of your site. And so, it's the first load that becomes the costly bit, which is what a lot of people are going to be concerned about.
If you're building like a blog or a content site, like, you're probably more concerned with first load. But if you're building a dashboard or an app and you're expecting repeat visitors, that's who this is really for today. And then, you're totally right that this is more of a long-term kind of, like, right now, the basic answer was like, well, there are these security vulnerabilities, so we're going to prioritize security and privacy and just disable this feature, which I think was probably the right choice. But there's other ways to solve that for this world once it exists that aren't just like, we won't allow this. You could do something where, okay, it has to have been loaded by 3 unique origins to it for it to be cached. So add a little bit of kind of noise to that. Start removing things from the cache kind of randomly and chaotically. So you can start to hide the fingerprinting, hide the security in a different way. But that really, like, the only reason to do that work would be that this world is like imminent. So we see it like there's more work on our end to do to show that and kind of paint that picture.
The other problem is that I think the browser cache is still pretty. At least I don't know if they maybe have changed this, but I remember like it used to be like only something like 300 megabytes or something like this. In which case, you know, unless you're going out of your way to do a service worker and like actually manually cache things, you know, you're going to end up, these common things like jQuery or whatever are going to end up falling out of the cache. But maybe that's changed. Maybe the cache sizes have increased since I last looked this up. So.
Yeah, and I mean, if you're talking about privacy, you know, I think Safari on iOS now essentially clears your service worker after a few days. Like they just saw that, okay, great, we gave you these primitives. We're now going to abuse that for advertising. Story of the internet that you aren't allowed to have nice things. So if you think of it that way from a privacy perspective, caching a resource is a really private way to just kind of like, you know, it doesn't give someone who's trying to track you as much as a service worker, which is essentially put whatever you want into local storage, you know, take control of a request even. It's a much more low-level primitive that doesn't give you as much wiggle room for abusing it for privacy, with the obvious caveats that we've discussed previously.
I do want to give a shout out to just on the absolute URL thing. One of the things that stuck with me from Ryan's talk 2 weeks ago was this pattern that's emerging in the Dino community of having I think it's a deps.ts file in the root of a project, which is a fantastic idea because then you don't need to do the whole rewriting of your dependencies. You can just call into your single deps.ts, and that references the absolute URL. And so in all your little files, you're using short requires, short import. I can see that becoming a model that might catch on and to get around this issue of really long URLs, especially if we go content address and the URLs get out of control.
Yeah.
That's a really interesting pattern.
The problem for web developers, though, is that once you then load that file, it's now loading all of it at once. So you lose the kind of like the nature of a website where everything's kind of separated by page, separated by only loading what you need. Import maps are a pretty similar concept for the web, though, and I think that Deno's exploring as well, that idea that you just have a mapping that says React means this, React DOM means this, and letting you write React in your code, but then actually just updating a map whenever you want to change that to a new version or a new host. That's a little more promising, but still, yeah, not a clear answer.
Wait, so question, Rod, is the deps.ts file, that's just like a mapping of like the string React to like the full URL where React is at, right? It's not actually like a single file that goes and imports everything and then exports it all as a giant like object, right?
My understanding was that it did do some of that exporting. In a sufficiently complex project, you could do a hierarchical view of that where you have a deps.ts in each directory that does it for you. But basically, when you want to reuse the same import, instead of doing the full URL, you call out to something that shortens it for you so that the repetition is lower.
Yeah,
you'd have to do it smarter. But what I really like about that approach is that it's something we can do with the tools we have now. We don't need to have fancy layering, build steps, all that sort of stuff. You can do it now and get the benefits of ESM and separate modules.
It makes a lot of sense for Deno, definitely. But it's a beauty and the limit of ESM where you need to be able to statically analyze the file to know what you need to load. So anything runtime with a mapping, it has any mapping has to kind of come as a primitive, has to come as some spec because the ESM file needs to be statically analyzable, for better or worse.
For us, how are we on time?
I think we have time for one last question, and then we'll do the social happy hour.
Woo.
I just want to make sure this new question isn't the one we should take. I'll throw this out as the possible question, which is, I don't know if you talked a lot about WASM being a part of the ecosystem, and I wanted to ask what you've been seeing on that front. So we could make that a candidate question. If anybody else wants to propose another.
I think that's a great question. Yeah.
Let's do it.
Yeah. I mean, I am more a JavaScript developer than a WASM expert. So it sounds like a great person to have on after me. Another talk for another time. But from what I've seen from playing around in this world is that idea that JavaScript, by virtue of being the language that we as web developers are familiar with, ends up being the most popular kind of just tool for the job. Webpack, Rollup, they're all JavaScript written. They get contributors from JavaScript developers. They get popular through that ecosystem, and by virtue of being popular, not the best tool for the job, they come into popularity. The idea that now WASM actually has a hook where it can kind of come in and do really intense jobs really well starts to let tools that maybe need a higher degree of difficulty to solve, or that aren't meant to be build anything on top of this. It's meant to solve one job really well. You can start to pull those in to solve that problem in a JavaScript ecosystem. So, I'm not a JavaScript absolutist that like WASM will never be the thing we build with as developers, but much more what's really seen success today is this idea of really kind of tight integrations with really powerful tools to solve really specific problems. And that's where WASM has kind of been seen to shine. So we use ESBuild really heavily, and it gets us a lot. But if you have if you look at it from the ESBuild side of things, they want to build a plugin ecosystem that is JS. They want to be the new bundler, and that means a different model, one where ESBuild is the lower level thing, and JavaScript becomes the thing that hooks into that. So it's not an answered question. There's plenty of takes, and I don't know where it'll go from here.
Axel Rushmeyer had an article up, I think, yesterday on his blog, Tuality, about how we're seeing more and more tools being written not in JavaScript.
Yep.
And he's got an interesting list there and just a discussion on some of the benefits and downsides. But it is an interesting trend to see, and WASM does come into play there. But there are other factors.
Yeah, it's one of those things where JavaScript's just so bad at this level of computation, where this single-threaded nature means it blocks, means you have to do a lot of work to spin up other workers. It's just night and day compared to a compiled language like Go or Rust. But JavaScript's still really good at I/O and coordination of those tools. So if I had to bet, I would say that JavaScript will still be the coordinator for tooling. If you're writing a JavaScript plugin ecosystem, it makes sense to connect those tools with JavaScript and then call into Rust or Go or a WASM compiled binary where it makes sense.
Cool. Well, thanks a lot, Fred, for sharing all that with us. And thanks, Paul and Rod, for joining us for the panel. Super awesome.
Yeah, thanks all for having me.
Of course. Cool. And thanks for all the good questions from the chat and from Paul and Rod. I think that was super interesting. I'm really excited now to actually give it a shot on maybe the next project that I start.
Yeah, I did see one question come in for how do I migrate an existing project. Check out snowpack.dev. We got docs on all of that, including that exact question. So yeah, exciting stuff.
Cool. All right.
Thanks, Fred. That was really interesting.
Oh, go ahead, Rod. Sorry.
I was just saying thanks. It was really interesting. Very thoughtful.
Yeah.
Thank you.
Cool. All right. So now we're going to go to the social happy hour part of the event.